So if you don't have your calculator out yet, make sure you have it. Even if you're not usually writing things down, you're going to want to have your calculator, because these calculators annoyingly are all programmed slightly differently. Some have a lot of similarities, but you're going to want to know how yours works, even if that means how your phone works or how the calculator you found online works, whatever. You're going to want it in front of you. Before we actually get to using the calculator, though, we need to talk about trigonometry, which is just this relationship that people found back in the day between angles and the sides in a right triangle. So I have a right triangle right here, and then there's an angle marked, which I have labeled X. So there's important parts to this. So just like we talked in the Pythagorean theorem, the hypotenuse is a very important part of the triangle to be able to find. The hypotenuse is, the hypotenuse is always found across from the right angle. So this would be my hypotenuse. Now the other two sides are called legs, but we're going to get a little more specific about those legs. One of those legs is going to be called the adjacent leg. One of them is going to be called the opposite leg. So adjacent leg and opposite leg. Adjacent is a fancy word that means next to. Opposite is a not fancy word that means across from. That's what we need to think when I talk about adjacent and opposite. So if I'm talking about next to, you have to be next to something. So in this case, what I'm next to or across from is going to be whatever acute angle is marked. So notice I said acute angle. The right angle only matters for labeling the hypotenuse. Once your hypotenuse is labeled, ignore the right angle, move to whatever angle is marked. So this is my angle that's marked. The adjacent leg is the leg, which is either this side or this side, that's next to my angle. This side is not next to my angle. Here, I'm like half running into this X. So in this case, my bottom leg would be my adjacent leg. It is not always going to be the bottom. These can be turned any old way. But this is my adjacent leg. And then this one here, when I trace it, I am not near this angle. This angle is on the opposite side of the triangle for me. Therefore, this would be my opposite side. So we've got these three sides, these three labels, and if I make fractions out of these three sides, we're going to get these new trigonometric ratios. So by that I mean, if I want to know what the sine of x is, sine is defined, like this isn't something you should know yet. Sine is defined as the ratio of the opposite leg over the hypotenuse. Which just means if this opposite leg was labeled with the number 4 and the hypotenuse was labeled as 5 inches long, then I would say the sine of that angle is 4 to 5, 4/5, or 0.8 if I'd put it in my calculator. It's just some ratio, but it's specifically the ratio of the opposite over the hypotenuse. Cosine is the ratio of the adjacent leg to the hypotenuse. So both sine and cosine rely on being able to correctly identify the hypotenuse. It just puts a different number up top. So I'd put whatever this length is over my hypotenuse. And lastly, something called tangent. Tangent is the opposite leg over the adjacent leg. So you don't have to care about the hypotenuse at all. You just take the two legs and make a fraction out of them, putting the opposite on the top and the adjacent on the bottom. Now you'll notice I'm calling them sine, cosine, and tangent, but that's not what these say. These are the abbreviations you'll see in your calculator, so that's why we have them written like that, but they're officially called sine, cosine, and tangent. That's their official names. These are their ratios. So let's practice finding them on number 1. So I just want ratios. I just want fractions. Simplest terms mean I am going to go through the steps of reducing, because that's what I need for a fraction. And I'm going to start with sine of t. So I'm going to review. Actually, before I even do this problem, I don't automatically know that the sine of an angle is the opposite leg over the hypotenuse. There's ways to memorize this, and that's what this little abbreviation up here is. This is a mnemonic trying to get you to learn it. And it's just pronounced Sohcahtoa. And it's just a way to say that the trig function that starts with s, which is sine, is O and H, opposite over hypotenuse, which is what we have written here. It's just a shorthand way to write that down. The cosine ratio, ka, adjacent over hypotenuse. Toa is the tangent ratio, the opposite over the adjacent. So it's just a way to try and help people learn what all of these are. It's not really anything new, it's just something to help us. Which means when I go to do a sine ratio, Sohcahtoa, so is telling me to put the opposite leg over the hypotenuse. So I'm going to go to my picture. First thing I'm going to do is say, okay, here's my right angle. This side is opposite my right angle. That makes 20 my hypotenuse. Which means when I go to do the sine ratio, 20 will be in the denominator because we put the hypotenuse at the bottom. But I have to have the opposite leg up top. Now remember, opposite means across from. Specifically, across from the angle. Now up here, my angle was x every time. It's not going to always be an x. So for in this case, you're not going to see an x anywhere in this problem. What I do see is the letter t. This is telling me go across from angle t. So I'm going to come over here. Angle t is up here. So there are two legs in this picture, two sides that are not the hypotenuse. One is the side of 16. You'll notice when I drew the 16, I started at t, so it's not across from t, it's right next to it. The other leg is the 12. The 12 is on the other side of the triangle, which means 12 is opposite. So this is my opposite leg. I misspelled opposite, but whatever. So now that I know opposite is 12 and hypotenuse is 20, I'm going to put 12 over 20. That is my ratio. And then I can reduce it. 12 divided by 4 is 3. 20 divided by 4 is 5. So the sine of angle t is 3/5. I'm going to do the same thing for cosine. Sohcahtoa, ka is A and H. I don't like it when it does that. So this time I'm going to need the adjacent leg and the hypotenuse. Conveniently, I already know my hypotenuse is 20. I just have to go find the adjacent leg. Remember, adjacent means next to my angle. This is my angle. The leg that's next to angle t is right here. This is my adjacent leg. Which means when I go to make a fraction of this, the adjacent leg goes on top of 16, the hypotenuse is 20, and when I reduce that, 16 divided by 4 is 4, 20 divided by 4 is 5. Cosine of t of 4/5. And then the last one, tangent, Sohcahtoa. This is reminding me that the tangent ratio is defined as the opposite leg over the adjacent leg. Now the super convenient thing is I've already labeled this whole picture. And so I don't have to go figure out this. I just need to say the opposite leg is 12 and the adjacent leg was 16. They're labeled for me. So I'll just put 12 over 16 and reduce it and be done with this. What's going on? So 3/4 when I divide both those by 4. So right now, I'm not using my calculator. I will on the next problem. But right now, I'm just practicing identifying these sides. One thing I do want to point out on this next problem is a slight change. It's still sine, cosine, and tangent. But if you look at the difference from this row to this row, the thing that changes is the letter. Now I want sine of g, cosine of g, tangent of g, which means the thing that I am adjacent to and across from is changing. So what I need to do in this problem is readjust where I'm going from. So this is my angle, not this one. Convenient thing, my right angle is not moving. Therefore, the hypotenuse doesn't change. So that's the nice thing. But if I switch this to the angle from which I'm labeling everything, 12 is not across from G, it's right next to it. 16 is not next to G, it's across from it. Which means, let me see if I can get this to work, which means this label is going to switch places with this label. My opposite leg and my adjacent leg have switched because 12 is next to G. 16 is across from G. So the legs are still legs, but depending on where your angle is, changes their label. And now I'm just going to write my ratios because sine is still so opposite over hypotenuse. And I just labeled the opposite leg as 16. The hypotenuse has not changed, it's still 20. And when I divide both those by 4, I get a reduced fraction of 4/5. Sohcahtoa. Ka is A over H. The adjacent leg next to G is the 12. The hypotenuse is the 20. I can reduce that to 3/5. Sohcahtoa. The opposite leg is a 16. The adjacent leg is a 12. When I reduce that, I get 4/3. But if you don't label your picture, this is going to be all kinds of confusing for you. Label your picture. It's your last chance to grab your calculator. I'm going to start a new video because this one's already getting pretty lengthy, but we will be using your calculator on the next ones, and it will be mathematically impossible to do it without a calculator. Get something up that is a calculator.